All right, for number 8, we have a polynomial, which is nice. We like polynomials. And we need to do intervals where f is increasing, decreasing. And then we have to do the same thing for concave up, concave down. Hopefully, we're feeling good about these kind of problems because we've quizzed on them a few times already. And it's a polynomial, so our life isn't going to be too difficult. All right, increase, decrease. This first derivative tells us that, right? So let's figure out what our derivative is here. We're going to have 3x squared minus 6x. Okay. We need to find our critical points first so we can make a chart where we determine everywhere else that f prime is positive or negative if we find the places that I'm positive or the places that I'm 0. Let's factor out of 3x here real quick. So I'm going to have x minus 2. Be careful when you're factoring, please. So either 3x is 0 or x minus 2 is 0. So it looks like my 2 points are 0 and 2. That means everywhere else, my derivative is positive or negative. So that's how I can go about this. So let's make a little chart. We like our charts where we see what's happening between our critical points. Okay, so f prime, f. All right, let's look back at this guy because this is what we need for our derivative, okay? So we need some test points. How about we do 1, 3, and -1, okay? If I plug 1 into my derivative, I'm going to have a positive number times a negative number. So I'm going to be negative. So I'm decreasing on this interval. If I were to plug in 3, I'm going to have positive times positive. So we're positive and we're increasing here. When I plug -1 in, I'm going to be negative, negative. Negative times a negative is positive, so I'm increasing here. Make sure to write out your final answer in interval notation because it asks for that, even though this is enough to determine it. So it looks like increasing, we're going to be negative infinity to 0. Be careful about saying like 1. Right? We're increasing all the way to 0. We just use -1 to figure that out. Union 2 to infinity, right? Again, 3 was our test point, but it starts increasing at 2. Okay? That means we're going to decrease between 0 and 2. And from our chart, we can see that 0 is a max because we increase up to it, and then we decrease, so that's a maximum. And then for 2, we have decrease and then an increase. We have a minimum here. All right, we're going to do the same process for concave up and concave down for our inflection points. Remember, inflection points happen when concavity changes. So we're going to have to find our second derivative. So basically just taking the derivative of this guy right here. So if we do that, we're going to have 6x minus 6. Set this equal to 0. I only have one solution this time, which is x equals 1. So again, do the same thing with the chart. But now we only have one number to care about. So let's look at maybe 0 and 2. Doesn't matter what numbers you pick. You could have picked -100 for all I care. All right. If I plug 0 into my second derivative, I'm going to have positive times a negative. So I'm negative. Sorry, that's a double prime. If I plug 2 in, I'm going to have positive times positive. So I'm positive. So we're concave down here, and then we're concave up here. Think concave up. The cup is upwards. The cup is up, right? It's an upward facing cup. In case you get those interchanged. Okay, so it looks like 1 is an inflection point because the concavity changed right there. And now let's write out our solution in interval notation like it asks us to. So concave up. After x equals 1, we're concave up for the rest of the way. So from 1 to infinity, and then concave down. We're concave down all the way up until we get to x equals 1.